Hello everyone, welcome to my channel. In today's video, we will discuss message switching. We have already discussed circuit switching in our previous video. In circuit switching, a dedicated path is established between the sender and the receiver. Then data transfer takes place. In message switching, it uses store and forward mechanism. A big data cannot be transferred from sender to receiver at one stretch. So it is broken into individual pieces or entities. And each of these pieces will be transmitted to the intermediate node. The intermediary node receives the small individual messages and constructs the full message. Then the message will be transferred to next intermediary node. In short, each and every node stores the entire message and then transfers or forward it to the next node. This type of network is known as store and forward network. Message switching treats each message as an independent entity. Previously, in message switching, the intermediary node stores the data in hard disk, which is slower. Now they are using RAM to store the data and forward to the next node, whichever is available or best path. In circuit switching, suppose A wants to send message to B, a complete dedicated path between A and B will be established. In message switching, there is no establishment of dedicated path between sender and receiver. The intermediary node will decide the path. The destination address is appended to the message. Message switching provides a dynamic routing as the message is routed through the intermediate nodes. The most efficient routes will be selected by the intermediate nodes. Now we'll understand this concept by seeing one example. Here sender wants to send a message to the receiver. The message will transfer to intermediate node. The individual pieces of the big message are collected and stored here. Then it will decide the next node, whichever is available and shortest. Then again, in the next node, all the individual pieces will be collected. First, it will make a complete message. Then it will forward that message to the next node. In this way, hop by hop deliver of the message will be done. In message switching, the complete dedicated path is not established. It will decide by the intermediary node dynamically. Message is reached to the receiver. In message switching, a dedicated path is not established. Hence, it will reduce the traffic congestion. Unlike circuit switching, it will not reserve all the devices. It makes traffic management efficiently. In message switching, the data channels are shared by all other network devices. Message switching supports message lengths of unlimited size. It does not require physical connection between the sender and the receiver. If we want to broadcast a single message to multiple receivers, it will simply append the broadcast addresses with the message. This is used by advertisement agencies for transmission of ads. This is also used by government agencies to transmit warnings and other security related messages such as tsunami, cyclone. Due to its storage mechanism, it is being used by police for criminal cases. Now we'll discuss some disadvantages of message switching. Message switching cannot be used for real-time applications as the intermediary nodes are storing the messages then forwarding causes delay. Not compatible for interactive application such as voice and video call. This is due to longer message delivery. It stores in the intermediate devices which requires large storing capacity in the intermediary nodes. There is no direct link between the sender and the receiver. It is not a reliable communication. In next video, we will discuss packet switching, which is the most important switching technique. Hope this video is beneficial to you. Thanks for watching.